Algebra 1 students, welcome to your 2.10 notes. And I do have to apologize for the book labeling a section 2.10. And that's because as Algebra 1 students, you guys know that 2.10 is essentially 2.1. So I will go ahead and apologize on behalf of the textbook. And we're going to go ahead and get started because this section deals with change expressed as a percent. So here's what we're going to do. The instructions say to tell whether each percentage tell whether each percent change is an increase or decrease. Then find the percent change. Round to the nearest percent. So here's how we do the first problem. We are going to take the original amount. We're going to subtract the new amount. And we're going to divide by the original amount. All right? So, the original amount, well, that's a difference of 5. All right? And that's going to be over 72. Okay? And the instructions say that when we calculate this, that we should calculate it to the nearest percent. When I plug this into my calculator, I get 0.0694. And as you guys know, percentages are always going to be in a decimal form, so we're going to round that to 7%. All right? All right, so in take 1 of problem 1, I forgot to mention whether it was an increase or a decrease, and in that particular case, it was a decrease. Sorry I missed that. The reason I realized that is because I'm realizing in number 2 that we have an increase. Okay, so in this one we are going to take our change, which is 68 minus 36. And that is going to be over our original amount, which is 36. And so we have 68 minus 36. That's going to equal 32. And we put that over 36. Okay? And that should give us our percent change, which in this case, it is basically 8 repeating. So we end up with a decimal 888 repeating. I'm going to round that again to the nearest percent, and again percent is in hundreds, so we move the decimal place over a couple of spots. Round up to 89%. And there you have it. Again, when we do these problems where it says on your own, I do want you to pause the video, actually try that, give it a shot on your own, and then come back to us here in a minute or two when you feel like you've completed that, and check it out. We'll show you our work. Alright, so hopefully you paused the video and gave number 3 a shot. I got approximately 31%. 16 minus 11 is 5. 5 divided by 16 is 0.3125. You can see how I got there. Alright, so in number 4, we're going to find the percent error in each estimation. Round to the nearest percent is our rounding as well. So, number 4, you estimate that a building is 20 meters tall. It is actually 23 meters tall. So what's the difference there? So we had a building that basically there's a difference of 3 meters. We're going to show our work here though. And if the building is actually 23 meters tall, well then that's our original amount. So that's what goes in our denominator there. So we have a difference of 3 meters over 23. And when we calculate that, which I do need a calculator, not gonna lie to you, 3 divided by 23 is going to be decimal 130 and some change there. So I'm going to go ahead and round that to 13%. And again, for those of you who need this. Percentages are always based on 100, so we just move the decimal place over 2 spots there. Alright, so in this one we have a salesman who is 45 years old, and he is actually 38 years old. So we take that difference, and our original, or our actual number is 38. So we take that difference of 7, and we calculate that. Again, I don't know how to do 7 divided by 38, so I'm going to calculate that with my calculator. I get a decimal point 1842. Going to round that basically to 18, move the decimal place over a couple spots, and that is a percentage of 18. Alright, in number 6, we are given a measurement, and we are to find the minimum and maximum possible measurements. So we've got a nurse measures a newborn baby at 22 inches long to the nearest inch. So that baby could really be anywhere from 21.5 inches to anywhere from there to 22.5 inches. Okay, so we would write that basically by just saying 21.5 to 22.5, and that would be fine right there. All right, so on number 7, the instructions say to figure out the bag of potato chips weighs 4 pounds to the nearest pound, and what could be the range basically of the weight in the bag of potato chips. Alright, this one wasn't too tricky. Hopefully you were able to figure that out. 3.5 pounds to 4.5 pounds is the basically the range of weight that this potato chip bag could have been. And let's go on to the next one. Alright, so the measured dimensions of a rectangle are given to the nearest whole unit. Find the minimum and maximum possible areas of each rectangle. So the first one we have is a 16 by 15 foot rectangle. And I mean, we could assume that's probably somebody's living room or something like that, but it's just kind of an approximation. So we're going to figure out what the minimum and maximum possible area is for each rectangle. And the area of a rectangle is basically length times width, right? So we know that we have a range in this that we could potentially have. So the smallest that one of the measurements could probably be is 14.5, and I started writing my foot there before I actually put my decimal point 5 there, feet, and it could range from there all the way up to 15.5 feet. Okay, and we also have another set of measurements that it could be. Well, our measurements could be anywhere from 15.5 feet on the other measurement all the way to 16.5 feet. All right. All right. So basically, what can happen here is we can have a minimum area if we were to have the smallest measurements possible multiplied by the length and the width. So our smallest possible length and width are 14.5 times 14.5. So that is our setup for our smallest possible area. And then our possible area could be the largest possible area that we have. So our smaller measurement and our larger, or our length times our width, largest possible measurements could be multiplied to figure out what that could have been. So if they underestimated the room by just a little bit, basically. So we've got 15.5 times 16.5, if that were the case. And so I'm going to use my calculator just to punch this in quickly. And the smallest possible measurement for the room would be, let's put some equal signs here, 224.75, and that would be feet squared. Okay, and then the largest possible measurement for the room, I don't like my equal sign there, let's clean that up. The largest possible measurement for the room would be 15.5 times 16.5, and that comes up to 255.75. And that again would be feet squared. Alright, so there is a little bit of a range there. If you underestimated the room by just a little bit, or if you overestimated the room by just a little bit, and that could be quite a difference there. Alright, again, number 9 says to attempt this one on your own. You've got a rectangle of 4 centimeters by 7 centimeters, and there is a degree of possible error there, so we're gonna check that out. And actually pause the video and try this one. Alright, so you can see my work that I did for number 9. We've got one direction of our rectangle could have been anywhere from 3.5 centimeters to 4.5 centimeters, and the other direction of our rectangle could have been anywhere from 6.5 centimeters to 7.5 centimeters. So we did one based on what happens if it was the smallest it could possibly have been, and the other one is what happens if it could have been the largest that it could have possibly been. And you do get a little bit of a range there.